here's a neat example. So we have this little medical robot, and this robot is hauling these 3 X-ray machines. And the X-ray machines are kind of attached, okay, as you can see there, right there, okay, by some kind of a rope or a string, right? And it's hauling this, we can imagine that it's hauling it in this direction. Now, the medical robot is exerting a force of 220 newtons forward, and there's an overall system, okay, which has a constant frictional force of 85 newtons opposing the movement. Now, each of these kind of X-ray machines that we have in here has a weight of 550 pounds. Okay, so I'm going to assume that this medical robot, okay, so is weightless, or at least it's negligible, okay, so that we're only worried about these 3. Okay, so before I start jumping, okay, into the questions which are asked of me, let me just kind of try to draw a schematic here for myself, or a free body diagram, which relates all of this thing together. So we have 220 newtons on the overall system, so trying to move it forward. We have a frictional force, so this frictional force is 85 newtons. And I have that each of these little X-ray machines, okay, so each of these, well, they're not so little, okay, so it's 550 pounds. So that means that the weight, so this is 550 pounds. Now I'm going to change this all back in, okay, to newtons, okay, for myself. So now let's recall, so we can have 1 newton is 0.225 pounds. And so I'm going to cancel this off in here, so that would have been giving me the exact amount. So let's see what this would be. So 550 divided by 0.225. All right, so it's quite a big force in there. So 2,444 point, and a bunch of 4s, and this is in newtons. Now, if you want, so because this is the weight, so don't forget that weight is equal to mass times gravity. Okay, so if you want the mass in here, so this right there, well, you can then certainly find that out, which is going to be what the actual weight is, and then divide this by 9.8, and that's going to give you what the mass is. So I'm going to actually do that all, since I have it on the calculator, and I probably will need it at some point. So the mass itself is equal to 249.433. I'll keep a few decimal places for the moment, and this would have been in kilograms in here. All right, so I have the mass here. If I'm going to need the weight in newtons, okay, so here it is. So these are all the given pieces of information. So now let's take a look and see. Hopefully we can answer all these questions. So part A says, find the net force on the overall system. Okay, so well, this one is very simple. So in order to answer part A, well, the net force is the summation of all the forces. So I have 220 minus 85, so this is going to be in the forward direction, right? So I can certainly do that minus 85. Then I have 135 newtons, and that is my net force. This is going to be to the right. I'm not rounding anything here at all. Okay, so I'm just going to keep it as it is for myself. All right, so that is the net force. All right, so let's see for part B. They're asking me find the acceleration of each X-ray machine. Well, the acceleration is going to be the same for all of them. So here you have to kind of be careful, because you're going to need to find what the acceleration of the overall system is. And of course, that means that each X-ray machine is accelerating at the same kind of rate. Okay, so in here. So that comes from Fnet, which in our case is 135 newtons. And that's going to be equal to the mass times acceleration. Right? So now I want to find acceleration. My mass is going to be the mass of all of these. So mass m1 plus mass m2, plus mass m3. And we said the robot is negligible. So I have this right here. I found the masses. So I guess those were going to be useful for me. So 249 point, I'll do this, so times 3. That's the total mass, so 748.299 right there, times the acceleration. And now solving for acceleration, so dividing both sides, so that's going to be 135 divided by the 748.299, or how many decimal places you kept there. So 135 divided by 748.299, and that's going to be, well, it's not very quick, but 0.18, okay, 04, etc. And this is equal to the acceleration, and that would be meters per second squared. All right. So that's my answer, right? So that's what I would have in here. Now, if you did want to round to, significant figures, and you want to keep it to the lowest amount, so as you can see here, so between the forces, really the lowest amount in there was 2. So you can certainly round that to 240 newtons, okay, if needed. And then for B, so if you were rounding it again to, to 2, that would have been 0.18 meters per second squared. Okay, so I'm just going to keep those there so that you can compare it, okay, in case that you were doing this example as well. Now, part C says, find the tension necessary to pull the third X-ray machine. So this is the tension right here that we want to be able to find. Now, this particular rope, it's only hauling one X-ray machine, right? So the tension that it's going to exert is only going to be on whatever, okay, the needed tension is to keep this guy kind of accelerating at that pace. So in order to do that, you basically just break this up. So you just have this one machine, and then you just say, okay, so what's the tension in there? So let me draw that out for you. So you'll have something like this, where you have, this one X-ray machine. Here's the tension, right? So for in here. Now, we know what the mass of this is, which is 249 point, I don't know, something, 433. Okay, so that's just of one. Now, we know also that this is moving or accelerating, right? So it has an acceleration of 0.1804, etc. in there. So the net force on this, which is just mass times acceleration, is going to be equal to that tension, right, that we have. Now, you might say, oh yeah, didn't we have frictional? Yes, we did. Okay, so we did have frictional, but we took that into consideration when we took the overall net force, and then we calculated the acceleration. Remember that this acceleration has taken into account that net force was based on, okay, the 220 and then the 85, which was the frictional force. So you don't add the frictional force again in here. Okay, you just simply take the net force, especially once you know the acceleration in here, and then that particular net force is going to be just the extra tension that now is needed overall. So this one isn't that bad. So we can take the acceleration itself, multiply it by the mass. So that's going to be, so notice it's about 45 newtons. So this is overall, so this is about 45 newtons, okay, in here. That's for one of these, okay, that we have. So that would have been for part C. I think I wrote B in here, so this is for part C right there. Okay, so that's the tension. All right, so for part D, it asks us, find the tension in T2. So that would have been this right here, so this tension. Well, this tension is going to be greater because now you're holding these two machines, right, as you're going through. So these are the two machines that you're hauling along. So these are the two masses. So the process is actually the same. So you're going to have now, these two machines, one machine, the other machine. But really, so this whole entire thing, right, that's your schematic there. And this is the tension that you're looking for. So you have, mass of the first one, mass of the second one, okay, that you have in there. So that's going to be twice the mass that we have over here. And then again, we have the acceleration already, right? So it's going to be twice as big. So the acceleration is the same. The only thing that changes, okay, is the fact that you have now twice the mass. So, you can convince yourself, but I already know, because if it takes 45 newtons for that first tension, this is actually going to be, so this is the mass times acceleration. Now keep in mind, you're adding the two masses, so 249 point whatever that was, plus the other 249 point whatever, and then multiply by acceleration, and you'll see that you're going to get 90 newtons, right? So overall in here. And then for part E, right, I kind of am foreshadowing. So it asks us about all three of them, and then what's the tension in the last one. For this one, I would highly encourage you. So that final tension that you have, which is going to be the mass of the three multiplied by, okay, the acceleration overall of the system. So this is going to be m1 plus m2 plus m3 multiplied by A. And of course, it should come up to 135 newtons, because that's exactly what we needed for the overall system, okay, to haul those machines. And that's because the medical robot that we had, okay, we neglected the mass for that. So that would have been it, right? So finding these tensions isn't that difficult, but it's a nice exercise, okay, that you have in here, especially for some elementary kind of or introductory physics courses, okay, if you're running into studying tensions and forces and net forces, right, frictional forces. This is an excellent example to highlight your understanding. All right, so that is it, okay? So thanks for watching. We'll see you in a future video. Bye, everybody.